Okay, so we're going to take a look at how to rewrite linear equations in slope-intercept form. And the type of examples we're going to be going through are the more advanced type of examples. So here's how we're going to go about it. We're going to explain what the slope-intercept form is, and then I'm going to show you the simplest steps to rewrite linear equations in slope-intercept form. After that, we're going to do some examples together so you can see how to apply the steps that are discussed in solving real examples. So what is the slope-intercept form? As a linear equation is said to be in slope-intercept form if it's expressed in this form: y equal to mx plus b, where your m is your slope and your b is your y-intercept. This is what it means to be in slope-intercept form. Now, how do we go about writing a linear equation in slope-intercept form? For you to be able to write a linear equation in slope-intercept form, you have to remember how to do literal equations. So, simply put, writing a linear equation in slope-intercept form is the same as solving the literal equation for y. And that simply means you have to isolate y, the y variable. And remember, when you isolate, you cannot have any number other than 1 as the coefficient of y. So let's see how we put all of this together as we solve some examples. So write the equation below in slope-intercept form. Remember that anytime you're doing math, whenever you have parentheses, you have to honor that first. So we're going to go ahead and distribute 5 into this expression, this parenthesis rather. So 5 multiplied by 2x, we have 10x. 5 multiplied by negative 7, we have negative 35. This is equal to negative 3y. So now we have negative 3y. You can see here that y is what we're trying to isolate, but it has a negative 3 here. This is a multiplication, so we're going to divide everything by negative 3. We divide everything by negative 3. So we're going to have here negative 10 over 3x plus 35 over 3 equal to y. So you can write, if you don't like it in this form, you can just write it this way: y equal to negative 10 over 3x plus 35 over 3. So now this is in slope-intercept form. Let's go through another example. 6x minus 11y over 4 equal to 5. So what you want to do here is you want to make sure that you eliminate the denominator here. There's an easy way to do it. So let's go with this. Let me write the equation: 6x minus 11y over 4 equal to 5. The best way to get rid of this denominator is to multiply both sides by the number in the denominator. Multiply both sides. So this is going to cancel this out. So you can see here that you now have just a regular, you're going to have a regular equation. So this is going to be 6x minus 11y equal to 20. So you have two things you can do here. You can either move the y over to this side. I would probably do that. So let me move the y over to that side, plus 11y plus 11y. So this is going to be 6x equal to 11y plus 20. And then I'm going to subtract 20 from both sides. So I have 6x minus 20 equal to 11y. So I have 11y, so I have to divide every single term in this equation by 11. So you divide by 11, divide by 11. So y is going to be equal to 6 over 11x minus 20 over 11. So this is your slope-intercept form. Let's do a few more examples. So we have 12 multiplied by 7x minus y over 6 equal to 8y. So what we're going to do here is let's deal with the parentheses first. So we can simply have 12 divided by 6. That's going to give us 2. So that is 2, 7x minus y equal to 8y. So now we're going to distribute 2 into the parentheses. We have 14x minus 2y equal to 8y. So we're going to add 2y to both sides. And we have 14x equal to 10y. Now we're going to divide both sides by 10 to isolate y. And so we're going to cancel this out. So let's cancel this. And we can simplify this. This is going to divide by 2, 7, divide by 2, 5. So y is equal to 7 over 5x. There's no intercept here. Well, the intercept here is 0. So you don't need to really write that. That's not necessary. So let's go through a last one. Now we have some fractions, but I know sometimes fractions can be confusing and scary, but fear not. Let's just keep going through this. So we're going to follow the principles. The principle is trying to make sure you can isolate y. So 5 over 8x plus 3y equal to 24. So we're going to subtract 5 over 8x from both sides because we want y by itself. So subtract 5 over 8x. So 3y equal to negative 5 over 8x plus 24. Now you're going to divide everything by 3, every single term by 3. And I want you to also see, when you have fractions, you can look at dividing 3 the same as multiplying by 1 over 3. So you can do that as well. They actually mean exactly the same thing. So this is going to cancel this out here. You have y equal to, and now you're going to have negative 5 over 24x, and then you have plus 8. Now let me just walk you through why I did that. So if I had to say something like 5 over 8 divided by 3. So when we are going through the division process, when you're dealing with dividing fractions by whole numbers, you're going to write this as 5 over 8 divided by 3 over 1. And then you know that whenever you're trying to perform a division with fractions, you leave the fraction on the left side intact, and then you change the division sign to multiplication, and then you will switch around the numerator and the denominator. This is 1 over 3. So that is why whenever you are dividing by a whole number, is actually the same as multiplying by its reciprocal, which is what we're doing here. The reciprocal is the inverse of, is inverting the numerator and the denominator. So this is pretty much how you would solve questions or equations, or convert equations from whatever form you're given to the slope-intercept form.